Hey guys, this is my first video on this channel, and first educational video on this channel. Uh, it is about AP Physics 1. Maybe this can help you guys if you're taking the AP Physics 1 exam, which is coming up in about a month or so, a bit more than a month. But I hope that maybe this video can help you prepare or review. This video specifically, as you can see, will be about the kinematics section, which is a pretty big portion of the AP exam. So without further ado, let's get right into it. So here are a few equations that you should be knowing throughout this unit. I've highlighted the ones that'll show up on the AP Physics 1 equation sheet. I numbered them. You don't need to memorize them by number. I don't memorize them by number, but I just put them in a numbered list there for you. I put a little table on your right, and with that you can try and recognize the potential, sorry, not the potential, but the variables that are involved in these equations. And so I'll just go over them each. So delta x is equal to velocity times time. For those of you in calculus, the velocity is the derivative of delta x. That might help you in terms of conceptually understanding it a bit better if you're in calculus. If you're not in calculus, there's nothing to worry about. So just keep that in mind. Also, velocity is equal to acceleration times time, and the acceleration is the derivative of velocity. So it's important to keep that in mind. If you're in calculus, it can help you. This doesn't really help unless you're in it can help conceptually if you're in Physics 1, but you'll need to know this if you're planning on taking Physics C later, particularly Physics C Mechanics. Then you have acceleration is equal to velocity divided by time, and this you can just see is like just a little bit. If you take the equation 2 and just change it around a bit, you can just get equation 3. So you can also interpret this another way, that the velocity is actually the integral of acceleration, and delta x for equation number 4 is actually the integral of velocity. And here's some of the equations that are going to be showing up on your equation sheet. You have the final velocity is equal to the initial velocity plus acceleration times time. I forgot to mention earlier, you should be memorizing all of these regardless of whether they show up on your equation sheet. I'll get into that a bit more on the next slide. So we also have delta x is equal to 1/2 times t of v plus v0. So that is an equation that can help you, assuming you don't have specific variables. You will need to memorize this because it is not in your equation sheet, but yeah, you should memorize that one. Then you have delta x is equal to the initial velocity times time plus 1/2 acceleration times time squared. So that equation does show up on your equation sheet. And then for the next one, you have velocity squared, final velocity, times the, is equal to the initial velocity plus 2 times the acceleration times distance traveled. Sorry about the background noise. So there are important things to remember. For starters, all the kinematics problems will require at most about 2. Well, the most basic ones will. I should have specified that in the slide. The most basic ones will require the equations. For bigger problems, they might require multi-step problems, and they require a lot more time. And your job is to find which ones are needed. Luckily, if you understand which ones are needed at which time, these problems can be particularly easy. So even though majority of the necessary equations are given on the AP Physics 1, I think you should memorize them personally. I wrote this down here. You can just read it off the slide, or you can hear my voice. It doesn't improve just your speed, because you don't need to constantly go back to an equation sheet if you've memorized them all. But it can also help conceptually. Like if you remember an equation, it kind of helps in terms of conceptually understanding why. Like if you want to scroll back a little, look at equation number 5. You can see that it kind of looks like the shape for a linear function. It kind of looks like the form of a linear function. That was actually a bad description. I'm sorry. Just ignore that. And also keep in mind, air resistance can be ignored, so don't worry about that. When I took the exam, they didn't specify this, and so you will not need to use air resistance. Bit of calculus knowledge, as you may have heard, I used derivatives and integrals to explain some of the first few equations. And this is particularly useful in kinematics. It is useful in a lot of other Physics 1 concepts, but I think for me personally, when I was understanding kinematics, I found this particularly useful. I was taking calculus at the same time as physics. So here's a basic one-dimensional kinematics problem. This is very basic, and it's highly unlikely anything this easy will show up on the AP exam. But it is good practice because it does show, like, can you use the equation properly? It is just one equation, by the way, you'll need to use. So I'll give you some time to pause the video. I'll read it once. A trolley moves down an incline at an acceleration of 3 meters per second squared and an initial speed of 1 meter per second. What is the speed of this trolley after 5 seconds? So try this yourself. Pause the video if need be. Alright, I'm assuming you've paused the video, and I'll go on. So how do we solve this problem? Well, for kinematics, I really thought it was useful and really helpful. I learned it this way initially, to make a table of what you know and you don't know. And I use this pretty much throughout all of kinematics. I think that a table is very useful at this. So you have what you know. So what we got from the problem, we know that the initial velocity was 1 meter per second, the acceleration is 3 meters per second squared, and the time it took was 5 seconds. We don't know what delta x is, but that's not what we're trying to find. We're trying to find, I labeled it as find, for the final velocity. So we need to find an equation that doesn't include delta x. And you may see it on screen. I accidentally went to it. That doesn't include delta x, but does include v. And it includes all these variables. And there's a perfect equation for that, actually. Equation number 5. It was on screen for just a couple of seconds just now. So you can plug in what you do know, what you have there, and conveniently enough, it's all to one side already for you. Solve it, you get v is equal to 16 meters per second. Again, like I said earlier, nothing this easy will show up on the AP exam, unless it's some really easy version. I highly doubt anything will show up like this. I didn't have anything like this when I took the exam. Alright, next. So projectile motion, this is something that could show up. Though I think this one is a bit easier. I believe that, I think it should be a bit challenging to understand conceptually, especially if you're doing this for the first time. If you're in review, I believe you should be able to do this if you know kinematics decently well. So Billy fires a cannon at an initial velocity of 300 meters per second at an angle of 30 degrees above the ground. The ground is completely flat, and the cannonball starts at ground level. What is the velocity with which the cannonball hits the ground? Again, try this yourself, and then resume the video when you are done. And picture the trajectory below in case you want to visualize, though I don't know how useful it'll be. I can't tell you yet. Alright, I'm assuming you've given it a go, so I'll move on to the solution. So how do you deal with a projectile motion problem? We do have all the tools we need. We just need a bit more